Hello and welcome everybody to this session. I'm Victor Cuadrado and with me is my colleague Raúl Cabello. In this session we will talk about Kubernetes security, how to secure our workloads and particularly about pod security policies. How do they look like, what they are for, and how does the world look like after they have been deprecated. Okay, so with that said, let's get into it. We hope that you enjoy this session. Okay, first thing that we need to talk about is security is a trade-off. I'm not the first one to use this XKCD comic in this kind of talk, and I'm not gonna be the last one. You can see here a cycle, no? Everything is interconnected at the beginning, which then brings bugs and security holes. And then we create sandboxes to just separate things and make things secure, but then we are back where we started. So everything is complicated again, and it's not so easy to operate with. This is something that we need to have in mind because we need to come up with the correct solution for our needs and our workloads in the cluster. Okay, with that trade-off in mind, how do we secure our cluster and our workloads? Okay, we can use the 4Cs, the 4Cs of cloud native security. In these 4Cs, we can lay out how do we need to secure our system. Here we have the 4Cs. The first C is the cloud or the data center. So basically the container and networking, the hardware that runs the whole thing. Then we have the second C, which is the cluster, where we deploy our workloads by using workload resources. So deployments, pods, jobs, replica sets, and so on. Those pods and deployments are going to end up deploying a container in the cluster, which is the third C. And inside that container, we have the option to set specific security settings. And inside that container, we are running our code, compiling or not, which is the 4C. And since we are talking about Kubernetes here, we care about the second C, the cluster, and the third C, the container. So let's focus on those. Okay, talking about the second C, which is the pods, deployments, and so on, those we can control who gets to instantiate those in the cluster or change them, no? Because we do API operations against the Kubernetes control plane, and those can be checked with RBAC. And then we can control who can instantiate or change those resources. Okay, but once somebody has access and has permissions to create or update or delete those, then they have access to set up the pod and the container however they see fit. And the pods and containers have in the spec, they have spec.securityContext, which allows us to set up what kind of settings we want. And that security context allows define the privilege and access control of that container, and then we are in a problem. So we need to check that spec of the pod and the container. How do we do that? Well, up until now, no, we have been using pod security policies, PSPs. Pod security policies basically are resources in the cluster, Kubernetes resources that we just instantiate and we define things. And these resources are being checked by an admission controller that comes with the cluster. And this admission controller is checking for requests for pods in the cluster and then goes through the spec. And if the spec is correct as how we have defined the pod security policies, it would allow it to be instantiated. And if not, it would reject it. We will talk later on about admission controllers. My colleague Raúl will do. Okay, we have this. And we have said that PSPs allow us to constrain the values on the spec.security context. These PSPs apply to all pods in the cluster, all of them. And they control everything that goes into the security context. So yeah, usage of all the host namespace and file system and so on, Linux capabilities, escalation of root, app armors, Linux and so on, what we will expect. How do they look like? They look like this. This is a minimal PSP. It's completely permissive. It allows everything. You can see that it's kind pod security policy, and that's it. And then it has a spec. This is not very useful. A useful one would be this, for example. Let's start with this, no? And this is a more restrictive one. We can see in the spec that first it allows for the host ports of the container to be open. So the container would have its ports from 80 to 80,000 open. And then it's not running as a privileged container. It's allowing some volumes to be there. It's dropping all Linux capabilities. It's setting UID and GID inside of the container, and it has only a read-only root file system on the container and so on. So this is more useful. And this would apply, if we set this up, would apply to all the containers in the cluster. Okay, if this is so useful, why are PSPs going away? Well, we are saying we have been saying that they apply to all the pods and containers in the cluster, which means that they are not namespaced. One can bind PSPs to entire namespaces by using service accounts and then the namespace and so on, which is a recommended practice. But then you need to craft your airbags, no? And then you need custom airbags per your workload, per your service accounts that you are using, and so on. This means that they cannot be enabled by default because they are custom to the cluster, which means that it will never be part of conformance, which is a pity because we want things secure by default. And apart from that, now we have a layer of indirection, no, with all the airbags and so on. And then how does one know which PSPs apply to which pods on which namespace and so on? It gets more complicated. Apart from that, on top of that, we have also poor composability. The PSPs are how they are. You cannot select so easily some settings and not others and so on. So then they are not granular enough. You can stack them. You can use several PSPs together. But then there's no prioritization model. It's alphabetical. It's by the name in the metadata.name of the PSP, which feels weird. What happens if you rename it? It's weird, no? And to complicate things, some settings on the PSPs are mutating. You set the setting, and then the admission controller would receive a pod request, see if it passes the definition on the PSP, and if not, it would maybe mutate the pod so it complies. But this only happens for some settings on the PSP, not all, and we need to know them by heart. And what happens when you are composing? Then you have one that is earlier in the priority that gets the request, mutates the pod, and then that mutated pod goes, without going to the cluster yet, goes to the next PSP that checks and so on. So it gets confusing. And on top of that, PSPs lack modes. They only enforce. They either allow things to happen or not. But you cannot set them in a way that they just allow things to happen, but they audit and warn you about what's happening. Which means that if you have already workloads in your cluster that you are looking forward to secure, you cannot retrofit them. You cannot put PSPs and see if they behave correctly with that workload, and the workload keeps working as it is intended. But yeah, so then you see where we are going. No, it's confusing. PSPs are nice, but they are confusing. So that's what people were thinking already in 2019. So in 2019, the community was thinking, okay, what do we do? PSPs are nice, but they could be even better. They are not as straightforward as they should be. We could fix them. We could change them and so on. But then that's complicated also, no? No one wants to fix them, but at the same time keep backwards compatibility and create a clear migration path for that. Which means that idea was dropped, sadly. So here we are in 2022. We know that PSPs are going away. In a month from this session, so in August 2022, we will Kubernetes 1.25 will be released and PSPs will be marked as deprecated. And now we need other things. Here we have two options. For example, the option that comes from the people working on PSPs and so on is another new in-tree policy mechanism called pod security. It's new in tree because the admission controller just comes with Kubernetes, the same way that the admission controller came with Kubernetes for pod security policies. This is a more minimalist approach. It has three standards, levels, privileged, baseline, and restricted, that we will see. And basically, it distills everything to essentials, and then you are always free to use plugins and complement it with other things. A third option is also the out-of-tree policy mechanism. Apart from pod security, you can just deploy your own dynamic admission controller, use the Wahoo ecosystem that Kubernetes provides you, and then do as you see fit. You were loving how PSPs works, then reuse them in a Wahoo model. or maybe you want to follow other things, or maybe you can do other things that you couldn't do with PSPs or port security. And with that, then the community can work towards a standardizing policy framework, and things can go on from there. My colleague Raúl will talk about this later, and I'm super happy of what he has to bring. Okay, so pod security. Let's explore pod security. Pod security, as I already said, it defines three standards. They are cumulative, so they go from highly permissive to highly restrictive, and the highly restrictive incorporates what has been done by the other two. Here we have the three. They are privilege, baseline, and restricted. Privilege is completely unrestricted. You can do whatever you would like. There's known privilege escalations that can happen if you just allow privilege as the standard. So that's one thing to have in mind. Maybe it's useful if you are debugging things in your control plane or things like that. Then we have baseline, which is minimally restrictive. Picture a minimal pod configuration, no specification, and if you try to deploy a minimal pod, you can with baseline. That's the idea. But it's not as secure as it should be. One should not target this as the default, if possible. And then we have restricted, which is super nice because the idea is that all the best practices on hardening pods and containers get incorporated into restricted, and then one can use it, and it's the one that one should try to get by default. Pod security get applied at the namespace level. If you remember, PSPs were for the whole cluster. Pod security gets applied on its namespace. It represents a step back, which is great because then everything is more simple. You can just set your standard in the namespace that you want, in your namespace that you want, and then you're done. And of course, you can keep using plugins apart from pod security. One thing that pod security has that PSPs didn't have is the audit modes. We will see them further on. And also it has defaults, which is great. PSPs didn't have defaults either. Okay, let's see the audit modes. We have talked about the three standards that you can set, and they would either allow things to happen or reject things. That's the enforce mode. There's three of them, no? There's three audit modes. We have the enforce mode that actually allows things to happen or rejects them. But the audit and warn are different. They always allow things to happen. The only difference is that they audit and they record things in the audit log of Kubernetes. It's just log events on the audit log of Kubernetes, and they go there. And then for last, we have warn, which also allows things to happen and triggered a user-facing warning. Let's say that you're using kube control for instantiating a pod. It would give you the warning when you instantiate that pod in the user-facing side of kube control. With that said, enforce only applies to pods. So we have all the workload resources, no, that one can deploy in the cluster: deployments, jobs, replica sets, and so on. All of those would get instantiated. Then, let's say, for example, a deployment tries to get instantiated. It has one replica, which is one pod, which will try to get instantiated, but then the pod security will reject it, which means that the deployment would be in a failed state, and that's it. But it's something that one has to have in mind. Okay, how does a pod security look like? Here we have one. This is a baseline one, and you can see the kind is namespace. So this is a namespace. We are just setting metadata labels in a namespace. That's all pod securities need. We just set the labels that we need on whichever namespaces, and we're done. Quite simple. Here we can see the labels. We have the two labels at the beginning, which enforce baseline. So we are setting enforce baseline, and then the version. Here would be 124. We are just hard coding that because we feel comfortable with that. But we could also set latest, which allows us to track the best the best practices as they keep coming. And also we can set the audit and warn directly here. Here we are setting them to restricted, so everything would get logged into the Kubernetes log, and the user would get a warning, which is great because we are getting a minimal security posture, plus we are getting notified by all the violations that we should be caring about. And with this, we can make our cluster and our workloads behave as we want them to be. And we talked also about defaults and exemptions. And we can set defaults for pod security. Pod security gets applied thanks to the admission controller of that comes with Kubernetes. And here we are just changing the configuration of that admission controller. We can see here kind admission configuration, plugins, pod security, and then we set the defaults. The defaults, as you can see, are very permissive as much as possible. Everything is privileged, and that's it. So one should craft the defaults as they fit, as they would like them to be, because if not, we are not doing much. Also, we have exemptions, which are nice. We can exempt usernames. So maybe we want our admins to create pods that are privileged, for example. Maybe we need that for debugging purposes. Also, we can exempt some runtime classes. Maybe we know that we are not using jobs, so we can exempt jobs and use jobs for doing things in the cluster that we would like to do in a different way, also for administration purposes. And also we can exempt namespaces. Maybe we need to do that because our workload cannot be changed, because maybe it comes from the community and we don't have the resources to do that yet. Then it's better now to have some security than none. So it's a good idea to just clamp on these things and diminish as needed. Okay, so we want to move from PSPs to pod security. How do we do it? It's not clear cut. It's not a one-on-one movement. This means that we really need to decide if pod security is for us. We need to look at our workloads, have an idea of how they behave and what do they want, what do we want out of it. Maybe look at the community workloads that we are using via Helm charts and so on also in our cluster. And then when we have that idea, we can craft the pod security that we would like to set, no? And then we go to our PSPs and we remove the mutating fields and we start migrating, so to speak. We go to the namespaces, we apply the pod security, we enforce it, and then we bypass the PSPs. And then let's see how it goes and so on, and then you disable PSPs and you're done. So basically, yeah, as it's expected, no? It's a rollout of pod securities with having in mind that PSPs do mutating things and so on. So let's see an example. Here we have the PSP that we were talking about in the beginning. It's a normal one, to be honest. It's something that one could use. And if one would be, one would go through pod security, options, they would realize that it matches pretty well with the restricted posture of the standard of pod security. The only thing that it doesn't work out is the host ports. Here in the PSPs, we are opening the host ports. Pod security doesn't allow us to do that. We could go to baseline, but it's a pity. And then here we would need to consider if we really want to change our workload, maybe create services in the cluster, whatever we need, but not open ports directly in the container. And maybe that's going to be good because it's a good security posture. Once we do that, then if that's what we have decided to go with, then we just have an analogy with the restricted pod security standard, which means that the pod security standard that we would deploy for this namespace would be this. Just set everything to restricted in enforce, and why not in audit and warn also restricted. We are following latest version, which is good, and that's it. Another option is to change the admission controller defaults. Instead of doing this by changing the pod security in the namespace, apply it to all the cluster, for example, and so on. Okay, pod security. They look like really nice, no? They are simple. It's easy to understand. I hope that I made a good job in explaining them, but they have trade-offs, as everything. Trade-offs. They're simple, no? I mean, they are all or nothing. This has upsides and downsides. The upside is that they are the same on any cluster that implements them. So then it's easy to test. It's easy to communicate with suppliers and teams, and maybe it's easy to take workloads from the community that have been done in mind with a specific pod security standard. So that's super good. it has the downside that maybe it's unrealistic to assume that your entire workload is going to fit in the restricted policy, and baseline it's not enough, which means that yeah, maybe you need to do things by hand or change your workloads, and sometimes you cannot or you would not like to do. Pod securities don't mutate things, which is a pity because sometimes you really cannot change workloads, and a simple mutation would solve a lot of things. They are only for pods and container images and workload resources. What happens if you need to secure volumes? What happens if you need to secure um, ingresses? Whatever is on the cluster can be secure, no? They are no context aware, so they don't know what's happening in the rest of the cluster and in the rest of the resources. And because they're only for pods and no context aware, they cannot do compliance audit checks. So it's not possible to go forward and maybe check for signatures of containers, software bill of materials, and things like that. Okay, so with that, I will leave you with my colleague, Raúl, that would go with the third approach. I hope that you enjoy it.
Thank you, Victor. So as Victor has already mentioned, there are several fields in pod security policy that are not covered by pod security standards, such as mutation. If you must enforce these options, you need to supplement pod security admission with an admission webhook. So let's see what's an admission webhook and how you can implement one. An admission webhook is basically a HTTP callback that receives admission requests, which can be a creation of a pod and an update on a config map, then performs some evaluation on this request, and it will reply with either, okay, yeah, go ahead, create this object, or it will reject it with providing an error message to the user. In order to create an admission webhook, we need to provide an HTTPS webhook server that needs to expose an endpoint for each webhook. There are two types of webhooks. We have the validating admission webhooks that can perform validation on request, and the mutating admission webhook, which in addition can also mutate or change the request. So let's see what happens when you try to perform an operation on your Kubernetes cluster. Let's imagine we, the users, want to create a pod in our cluster. So the first thing that happens is the authentication and authorization. If we are authorized to create this pod, then the mutating admission webhooks will be called. They will mutate our pod request, and after that, we will perform an schema validation. If that's okay, we will pass on to the validating admission webhooks code. It will call all the webhooks we have here. If one of them rejects the request, then the user will see an error message and our pod will never be created. On the other hand, if all the validating admission webhooks are done, okay, yeah, go ahead, create this request, then your pod will be stored in etcd, and that's it. So let's recap. What do we need in order to create an admission webhook? First thing, you need to provide an HTTPS server, and it has to be HTTPS. So you need to create the certificates, and you need to pass the CA you used for issuing these certificates to the webhook, so they can establish a secure connection. Then we need to expose an endpoint per each webhook, and we need to create the webhook object itself. There are different tools that help us with this process if we don't want to do everything manually. They're called policy engines, and today we're going to talk about Kubernetes, which is an open source project that belongs to the CNCF sandbox. Victor and I were both working at Kubernetes right now. So Kubernetes integrates with Kubernetes by providing a set of custom resources that simplifies the process of enforcing policies in our cluster. The first resource we have is the policy server, which is the HTTPS server Kubernetes creates. And then inside of this server, each policy is exposed using a dedicated endpoint. Policies are isolated from each other and from the host. That's because they run inside of a WebAssembly module. So they run inside of a secure sandbox. And we have two custom resources for policies. If we want to evaluate cluster-wide resources or resources in the whole cluster, we can use a cluster admission policy. And if we want to evaluate resources on a specific namespace, we can use the namespace resource admission policy. So let's see how keywording works. So here we have the custom resources for the policy server and cluster admission policy. These are the resources we as a user can create. Every time we create a policy server, there is the keywording controller, which is continually watching for new resources or modification to the existing ones. And it will be in charge of creating the HTTPS server. We create a deployment, the service with different replicas if we want to achieve highly availability. Then it will instantiate each policy in the policy server, and it will provide an endpoint inside of the policy server for each policy. Same happens for the policy. The controller is continually watching for new policies. Once we create a new policy, the policy server will instantiate the relevant the policy in the policy server it's bound to. And once the endpoint is up and running, then it will create the webhook configuration. So why WebAssembly? Because just out of the box, we get the benefit of the security. WebAssembly modules, they run in a very secure sandbox, and it's not possible to escape from there. Then you can reuse your existing knowledge in a specific programming language. That's because multiple languages support compiling to WebAssembly. Currently, keywording supports writing policies in Rust, Go, Swift, AssemblyScript, and we recently added support for C#. WebAssembly module can be distributed in OCI registries. So if you're already using an OCI registry for your containers, you can reuse it for the WASM modules. Also, policies can be executed outside of Kubernetes. That's very useful when you are testing policies or when you are developing a new policy. Actually, keywording provides a CLI tool that allows you to execute policies outside of Kubernetes. Okay, so let's see how a policy looks like. This is an example of a capabilities policy. So we have here the module, as you can see. This is inside of an OCI register. And here we have the rules. These are the objects, the resources we are going to evaluate. In this case, we are going to evaluate pods and just the creation and update operations. This is a mutating policy. That means that can mutate the pod request. And here we have the settings. In this example, we are saying, okay, allow these two capabilities, chown and kill. That means that if you try to create a pod that contains a capability that's not listed here, it will be rejected. And we're adding by default this capability, chown, which means that even if you don't provide this capability, this policy will append it to the pod. That's why it's a mutating policy. So yeah, let's see this in action. So let's create the policy. This is the same policy I spoke. Okay, now let's wait for the policy to be active. Okay, it's active. So first, let's see what's happening. So keywording created a webhook object for us, a webhook configuration. It's a mutating because we said that it was a mutating policy. We have here the CA bundle that it needs to establish a secure connection to the HTTPS server. We have here the endpoint that the policy server created for this specific policy. And then we have the rules, which are the objects we are going to evaluate. In this case, it's the resources, the pods, just pods, and in this operation. Okay, so now let's try to create a pod that contains a capability that was not listed there. Okay, as you can see, it could not be created, and we have here the error message. And now let's try creating a pod without any capability. As you can see, it was created, but we added by default one capability, the CSON. So let's see the capability of this pod we created. Okay, it has CSON. That means that keywording mutated the request. It added this capability to this pod, even though we didn't specify. So yeah, this is how Kubernetes works. I think it's very easy. You just need to create this YAML and everything will happen behind the scenes. So let's talk about PSP migration, how you can migrate from PSP to Kubernetes. There is an excellent script wrote by the AppVia team. This script, it's reading all the PSPs you have in your cluster, and it translates to policies into it works in with different policy engines. One of them is Kubernetes, but it also has support for Cabello, Gatekeeper, and Krail. There is an excellent blog post that defines how you can migrate using this script, but yeah, let's see it in action. So yeah, we just need first, let's check the PSP we have. This is a typical PSP you can have in your cluster. It's actually the same example Victor showed earlier. So once we have it, we just need to execute the script and that's it. That's it. So the script, what it did, it read all the information about the PSP. It transforms the PSP into Kubernetes policies, and then we apply them. So yeah, one line and that's it. You have all the PSPs. You can now remove the PSP and the policies will do exactly the same job. If you want to inspect this, you can export the output of this script to a YAML file. Then you can see what the policy is, how the policy looks like. And you can also change the mode because Kubernetes policies support a monitor mode. So policies will not, resources will not be rejected. They will just be locked. The action will be locked. But yeah, you have seen how easy it is to migrate thanks to this tool. Okay, so what are the benefits of Kubernetes compared to creating your own webhook or using PSP pod security standard? First thing is you don't need to write a webhook server. You don't need to handle complex certificates. That's all being done by Kubernetes for you. You can verify any Kubernetes resource, not just pod. If you are using the deprecated PSP or pod security admission, they work just for pods. You cannot evaluate a config map or any other resource. With Kubernetes, you can evaluate any resource you want. It also has support for mutating policies, so you can mutate requests. There are already a lot of policies defined in Artifact Hub. You have all the PSP replacement and many more. So before writing your own policy, please go to Artifact Hub and check if someone already wrote a policy for that, so you can reuse it. If you are using PSP, you have seen how easy it is to migrate. You just run the migration script and that's it. You have the relevant Kubernetes policies. As we have mentioned earlier, because we're using WebAssembly, you can run policies in your favorite programming language, so you don't need to learn a new language. Then also there is the Sigstore verification capability. You can verify Sigstore signature with a verify images signature policy, which it's very useful if you want to secure your supply chain. Okay, so we talk about pod security admission, PSP being deprecated. We also mentioned you can supplement pod security admission by writing your own admission webhooks. And we talk about Kubernetes. So how does everything fit together? Should you be using just one of them? Can you use both of them together? And the answer is yeah, you can use both of them. In PSP, they are deprecated, so you need to move from that. You can move to pod security admission. It's very easy. It's already built in inside of Kubernetes. So it should be very easy to start using it. But there are certain limitations Victor spoke about. You cannot do everything you were doing in PSPs, and even things that could not be done with PSP, you can do it by writing your custom admission webhook. And if you want to simplify this process and use existing policies, you can use keywording, which simplifies this process a lot, and you can reuse existing policies or create your policies if you want, which gives you a lot of flexibility. So that's all we wanted to tell you today. This is our information in case you want to reach out, or if you want to help us support keywording, please feel free to reach out, Slack, GitHub. If you want to contribute, you are welcome. If you have any question, please write them here in the chat, create a GitHub issue, or any of these way of communication. So yeah, thank you for listening.